Yeah, so live streaming has also started.
Okay.
You may start.
Thank you. Thank you. So, good afternoon to everybody, and welcome to this fourth session on foundation course in mathematics under this OFCM 2021. So basically, so far we have been dealing with statement and its negation, right? We will look at today some statement, but we'll also look at what is called implications. So sometimes you have more than one statement, and one statement may depend upon the other, or it is implied by the other. So we'll try to understand such statements. We generally come across such results as there are some conditions given, and then you have some conclusion, right? So, and then you know that there are different ways of proving such things. So it is important to understand those statements. So let me share the screen. Okay, so let me write a few statements, maybe just 2, 3, and then we'll see what it means. So we also look at when such statements are true, when it is not true. So the first statement is as follows. Let us say it says that first one, if the apple is red, then it is ripe. Okay, that's the statement. Okay, so you can see here, this is actually a combination of two statements. One is the apple is red, that is one statement, and it is ripe is another statement. Okay, so if I call this statement as, let us say, let me denote this statement by S and this by T, then it says that if S, then T. Okay, let me write another statement. If I go to the market, then I will buy, let us say, cake for you. That is second statement, right? If I go to the market, then I will buy cake for you. So this is again very similar to, so here, this is one statement. I go to the market, and then I'll buy cake for you is another statement, and it is combination of this. Here again, if this is true, then this is true, right? If I go to the market, then I'll buy cake for you. Third one, let me give you the third statement also. The third statement says the following. The boy is a graduate. That means he has done his graduation. If he owns a, let us say, some BMW car. Okay, this is third statement. Right. So again, here you also have here also there are two statements. One is that the boy is graduate and he owns a BMW car. Right. So if you look at, for example, third statement, right? What does it say? The boy is graduate. When? If he owns a car. So you can also write this statement as like if the boy owns a car, BMW car, then he is graduate, right? So this statement is very similar to the previous one, right? So again, we have two statements that the boy owns a BMW car and the boy is graduate. Okay. Now, so all these statements, one can think of this as something like this: if S, then T. If S, then T. This is kind of, all these statements are of this form. Now we would like to see when is this statement true, when it is false. Before I look at that, see, in the same statement, there are different ways of writing. Already I have given you two ways of writing the same statement, right? The boy is graduate if he owns a car is equivalent to if the boy owns a BMW car, then he is graduate, right? Okay. So let us say this statement. So so let me write this equivalently. So first, the standard way of writing is this. So let me write this as if S, then T. That is a statement. And just now saw that equivalently we can write this as T, right? We can say T if S. That's what you have right here. He owns a BMW car when if he is graduate. If he is graduate. So that's what he is writing, right? T if S. So this is another way of writing, another way of saying. Can you think of the same statement writing in some other way? Same statement writing in some other way? Or in mathematics, let us say you must have seen similar statement written in some other way. Can you think of? Can you think of? Yes, Alina?
S implies T.
Very good. This is S implies T. That is another way of saying this statement. S implies T. Very good. Okay. Sorry, I think I cleared the response. Somebody else had also. Maybe you can click again if you have some other way other than these three. You can tell me. Akhila, tell me. You have some other way of saying?
Yes, if and only if. Yes, if and only if T.
Does it say if and only if?
Yes, only if T.
Which only if T? Which only if T? You want to say S?
Yes,
Only if T. S can happen only when T can happen, right? So
yes, sir.
in this case, if you look at the first statement, the apple is red, then it is ripe, then so the apple can be red only if it is ripe, right? That's what is, that's correct. That is correct. Is there any other way of saying? Is there any other way of saying? Sometimes you see, we also, you must have seen something in necessary, sufficient, etc. Right? Sometimes it is written that way. So can we say something on that line? Which is necessary, which is sufficient in this case? Which is necessary and which is sufficient? If I say the apple is red, then it is ripe. The S is the apple is red and T is it is ripe. Which one is necessary? Which one is sufficient? Or both are necessary and sufficient? That's not correct, right? Yes. So in this case, here T, what is T? The apple is ripe. This is necessary for S. And the other way around is that S is sufficient. S is sufficient for T, right? For apple to be ripe, it is sufficient that it is red, right? For apple to be ripe, it is sufficient that it is red. Okay, so these are different ways of writing the same thing, that if S then T. Okay, many times we write something, this we will write as S implies T in symbols, right? Or S only if T for S to happen, that is necessary, right? That means if S, so what does it say? If S, that means if it is red, then T has to be right. That means the apple has to be right. Okay, so these are equivalent ways of saying this same statement. Now let us look at when is this if S then T, this statement, when is this true? When is this true? Okay, or when is this false? So let us look at this one just for, I think possibly this is slightly more appealing. Of course, all are similar in nature, but this is slightly more appealing. So what does it say? If I go to the market, then I'll buy cake for you. Okay. So when will this not be correct? When will this statement not be correct? When will this statement not be correct? Yes. What is the condition? If I go to the market, when will I buy the cake? There is a condition for that, right? There is a condition. Somebody from group 1? Somebody from group 1?
Iqbal? It will not be correct if A does not go to the market.
There is a, you are just saying only one part, right? This has there are two statements. So you are just saying about one part. So that's not both. This entire, the whole thing is now combination of two statements, S and T. So that's not sufficient what we are saying. Yes. Somebody else from group 1? Somebody else from group 1?
Siona.
Yes, Siana.
If I do not go to the market, then I will not be able to buy cake for you.
Come again. Your voice is slightly low.
If I do not go to the market, then I will not be able to buy cake for you.
But that is true, right? That is true. If you don't go to the market, you're not bound to buy cake, right? So of course you not buy cake. So this is same thing, right? Okay. This is somebody from group 2.
Jane.
Yes, Jane.
I go to the market and not buy a cake for you.
That is correct. That's correct. If I go to the market and I don't buy cake for you, that means this statement is not correct, right? If I don't buy cake for you, right? Then and if this statement is correct, if I don't buy cake for you, then can it happen that I have not gone to the market? I have gone to the market? No, right? If I don't buy cake for you, can it happen that I have gone to the market? No. So only when this statement is correct, I mean, if this is not correct, it means that if I go to the market but I don't buy cake for you, then this statement is not correct. Is this clear to everybody? Let me clear the previous response. Let me clear this previous response. Is this clear to all of you? So the moment you say if you don't go to the market, then I mean, if I obviously I may not buy it, so there is nothing, there is no compulsion. So the only this statement is not true only when if I go to the market but I don't buy cake for it. So what does it says? If I look at now, if I look at this statement that if S then T, if this is not true, so that means the negation of that is going to be if S happens, but T does not happen. T does not happen, right? That's the 1 second. That is when this statement will not be true. Okay, so not true when if S is true, but T is false. If S is true, but T is false. Okay, or you can say S, but not T. You can say S, but not T. That's the right. So this is what we mean here. So if you have to negate this statement, this is how you will negate this kind of statement. Now somebody was just saying it is if and only if. So now if I have, so for example, if I have or if I just look at this statement, the first statement, what was the first statement? If the apple is red, then it is ripe. Okay. And many times you have to say what is converse of a given statement. What is converse of a given statement? So what will be the converse of this statement? Converse of this statement, apple is, if the apple is red, then it is right. What is converse of this statement? Okay, so let me clear the response, all the response. think what will be converse of this statement? Should not take that long. Somebody from group 3?
Chandrendu.
Sir, if the apple is ripe, then it will be red in color.
Yeah. Correct. So, see, it is if S then T. So what will be the converse? If T then S. Right? So it is if the apple is ripe, then it is red in color. Red. Let me write this. Start the converse. This is what we call converse. So in first one, your given condition is S, and then you are concluding T. Right? So the converse will be the other way around. Now T will become the given condition and S will be the conclusion. That is say by saying this I can write as S implies T. This is, if I call this as S, this S implies T. The converse will be T implies S. Right? So in case this is true and this is true, both are true, then we can say the apple is red if and only if it is ripe, or S if and only if T. Or if you now compare this, what I wrote this equivalent condition, then we will say that S is necessary and sufficient condition for T, or vice versa, T is necessary and sufficient condition for S. So this is how we write many statements, right? When you have necessary and sufficient condition, this is what it means. Okay. So because many times when you are given to prove that some statement of this nature, which one is necessary, which one is sufficient, there is always some kind of confusion. Okay, so always keep this in mind. If you have a statement which is like this, if S then T, this means that T is necessary for S and S is sufficient for T. So we can write S if and only if T, or we can write S implies T, T implies S, or S if and only if. Generally we write this as IFF, or if and only if T. Okay, so these are just different ways of writing this statement. Okay. So let me also possibly look at some example where we come across this, and you must also, you can try to possibly contrast with some results that you have seen. One of the results is something like this. You must have been looking at if f is differentiable, then can somebody complete? Can somebody complete? If f is differentiable function, okay, I'm not telling you domain and codomain, so it is of f is from. I did not ask you to say orally, right? Okay, so you are saying that then f is continuous. Now again, you can see here, can a function not be continuous and differentiable? That cannot happen, right? That cannot happen. And if f is differentiable, then it cannot happen that it is not continuous. So if this is not true, that means what? F is differentiable, but it is not continuous. But that doesn't happen. This is already we know this result. And something similar you can must have come across. Let me give you another. So do all of you know how to define modulus of a real number? If x is a real number, how do we define mod of x? How do we define mod of x? Let me clear all the response. How do we define modulus of a real number? Somebody from group 5?
Nandana?
Mod x is equal to minus x for x less than 0 and x for x greater than or equal to 0.
Okay, so you're saying it is minus x if x is negative and is equal to x if x is greater than equal to 0. So if it is 0, then x. If it is positive, then also x. Okay, this is any other way of defining? Is there any other way of defining? This is correct. This is what this is what you must have seen in your class or in any book that you are following. Let me give you this slightly different definition. So you see that here what you have is, yes, Mainak?
Sir, we can write mod of x as the positive square root of x squared.
Positive square root of, so you're making it more complicated. Yeah, so this is how you're touching your nose, right? Okay. Right, okay, but say that involves the existence of a square root, etc. That does not complicate. But you see here, this there are two things, that x and minus x. There are two things. So if you try to plot graph, I'm sure all of you know how to plot graph of function y equal to x and y equal to minus x. So let me plot graph of y equal to x. This is graph of y equal to x. Generally, my drawings are not good. Let me try. Okay. This is y equal to x. Let me draw y is equal to minus x. So this is y is equal to minus x. Okay, so I have to now, if you look at y is equal to mod x, so what does it say? When x is negative, then what is happening? I will consider this graph, that is y equal to minus x. And if x is non-negative, then I will consider y is equal to plus x graph. Okay, that's what it says. So that means if you compare between this and these two graphs, this side, this fellow is above this. Whereas on the right hand side, this fellow is above this one. So that's so this side we are considering this one, whereas when you go to this side, you are considering this one. Okay, so this is your mod x. So now, can somebody tell me what? Can somebody guess what should I write this as a definition now, as another way of defining thing? I have said this on the left hand side, this y equal to minus x is above y equal to x, and on the right hand side, y is equal to x is above right? So that should give you some new way of defining. Yes. Anybody else? Anybody can think of? So we are comparing x and minus x, right? Y equal to x and y equal to minus x. When I say comparing f of x, think of these as two functions, f of x, g of x if you want. Then what are we doing? This one left hand side, this is above this, right? On the to the right of 0, y equal to x is above this. So in particular, we are taking the maximum of the two, maximum of x and minus x. Whichever is maximum, you take that. You see that on the left hand side, minus x is maximum. To the to left of origin, minus x is maximum. To the right of origin, plus x is maximum. Okay, so that's what. So you are combining these two and writing as a maximum of this. This actually, this if you define this way, many things becomes actually very easy to prove. In any case, let us look at. So once you have understood this modulus of x, let me see. So if I have a real number x, let me write it in black. If I have real number x, and let us say fix a some positive real, or let us say 1. Suppose mod x is less than 1, mod x is less than 1. What does it say? What does it say? This, if mod x is less than 1, can we conclude something? Can we conclude something from this? If mod of x is strictly less than 1, can we conclude something from this? So this is your one statement, right? If this, I'm asking, if, so let me write, if is not required, if this, then I want to say something. Whatever comes to your mind, please do not hesitate in telling. See, if you make mistakes, from there we can get the correct answer. Somebody from group 2?
Sir, if mod of x is less than 1, then it implies that x lies strictly between -1 and 1. Or we can say that -1 less than x less than 1.
Okay, so you are saying that then x, you are saying x lies between -1 and 1, right? So x,
Yes.
-1 is strictly less than x, and it is right.
Yes, sir.
This is equivalent to saying that x lies, that is x lies in the interval -1 to 1. Okay, so that's the right. Now you see that if I have to if I need to prove this, and if I use this definition, what was my definition? Mod x is maximum of minus x and x, and this is less than 1. You see, what does it say? If the maximum is less than 1, each one will be less than 1, isn't it? 1 x is less than 1, which is this side. Minus x is less than 1, this is this side. Do you see that? If I use this as definition, proving that mod x is less than 1 implies x lies strictly between -1 and 1. It just follows from the definition. It just follows from the definition. Okay. Now can we say the other way around? Is the converse also true? Is the converse also true? Is the converse also true? So now what do I have? If mod x is less than 1, then it implies this. So what will be its converse? We have already seen how to write converse. Somebody from group 5? Somebody from group 5?
Devika.
Yes, Devika? Yeah, tell me.
If minus 1 less than x less than 1, that is true, then the mod x will be less than 1.
Okay, so the converse of this is going to be if this is true, that is minus 1 less than x less than 1, this should implies mod x is less than 1, right? Is that correct? Is that correct, Devika?
No, sir.
No. So if you're saying that if x lies between minus 1 and 1, this doesn't imply that mod x is less than 1. Okay. Somebody else from group 5? Can you call out some?
Yes, sir.
Yeah, tell me. Have you understood this is the converse?
Yes, sir. I understood it
Okay.
is a
Now, what do you
converse.
think? Is the converse also true or no?
I think it's true.
You think it is true. So
I'm not sure.
So this is what you are assuming, right? You are assuming that this happens. These are two statements, isn't it?
Yes, sir.
When I say minus 1 less than x less than 1, this means that minus 1 is less than x. That is same as saying x is greater than minus 1, right? Correct? Another one is x strictly less than 1. X is less than 1. So from these two, if x is greater than minus 1, if x is less than 1, what can we say about the maximum of this? Or okay, so let's just keep. Let's keep it in this. We should always keep in mind what we want, right? From this, we want to conclude about mod x. What is mod x? Maximum of x and minus x. So if both are less than 1, this maximum will also be less than 1, right? And what does it say? What does it say about x? X is less than 1. X is already less than 1. This fellow is less than 1. What about this fellow? What about this fellow? Minus 1 is less than x. So what does it say about minus 1 is less than x? So what does it say about minus x? What does it say about minus x? If you multiply both sides by minus 1, what will happen? If minus 1 is less than x, if I multiply both sides by minus 1, what happens to the inequality? It changes, right? Therefore, 1 will be greater than minus x. That is same as saying minus x is less than 1. So again, that happens. Is that clear? So these two together implies that this is less than. Okay, therefore, this is also true. So what we have achieved that this is if and only if condition. That is same as saying I can write mod x less than 1 if and only if x or minus 1 less than x less than 1 or x lies in the interval minus 1. That's the okay. So you see that in order to prove this kind of thing, first we assume that it implies this, we prove, and the converse is that we assume this and then we prove this one. So this is how many statements that we generally come across are of this kind. This is one such. Okay. Is this proof clear to everybody? let me give you maybe 1 minute. Please go through the argument that we have done, and once you are able to complete the argument, both if mod x is less than 1 implies this, and the second if this is given, that implies mod x is less than 1. Once you are able to complete both the statement, then you click on yes. Okay, let me clear all the response. Okay. Take 1 minute. If you get stuck after some stage, you start all over again. But don't give up. Give up. Okay, so only 21 people are saying they have got it. Okay. Megha from group 9. Megha. Hi, Megha.
Yes, sir.
Yeah. Where did you get stuck? Which part do you have problem? Megha, have you finished the proof?
Yes, I forgot to press yes.
Okay, that's not something, unnecessarily. I'm just. So please honestly click yes if you have not followed, no, or if you have some question, raise hand. Okay, so that we don't have to wait. Okay, so anyway, so I think majority of you have followed, but those who have not followed, please discuss. But in fact, even if you have followed, please discuss this in your group. Discuss. Okay, mentors, please make sure that somebody, even if everybody has followed in the group, one of them should explain the proof to others. Okay, please take care of this. This is the first time we are actually writing proof of some concept, right? Okay, now let us look at. So again, let us look at the same statement that okay. So if the apple is red, then it is right. Okay, so this is, let us say, we consider this is a result. If this, I say that this is a result. Okay. Now, so what is So in this result, what is given to you? You are given this. The apple is red. What is that you want to prove? This is right. Right? For example, just now we did, if mod x is less than 1, then what we concluded? X lies strictly between -1 and 1. Now suppose if this is not true, if this is not correct, if the apple is not right, then what can you conclude? Can we conclude something? Can we conclude something? Conclude something means we have to say something about the other statement, right? That's what it means. So here it is, if S then T. So we are saying T is not correct. Then what can happen? Somebody from group 6?
Aradi.
Sir, then the apple is not red.
No, that is my thing. I have said if the apple is not ripe. That is what I have said. So what can you conclude?
If the apple is not red, then it is not red in color.
Then it cannot be red in color. Very good. Then it cannot be red in color. Then it is not red. Why? Because if it is red, then it has to be ripe. This is what you want to conclude, no? So if your conclusion is not correct, that means what? If it is not, then it is not red. If this is not correct, means what? It is red. And if it is red, then what the given statement says that it has to be ripe. So what you are assuming is not correct. Okay. So that means these two are the same thing. This what we wrote, this is equivalent to this now. Right? So this is equivalent to this. Both are equivalent. Okay. If we assume this, then we are saying this. But if it is not correct, then this cannot be correct. So then this one, this is equivalent to this. So many times when I have to prove something, some statement which is like this, instead of proving this, we prove this statement. That is, if the apple is not right, then it cannot be correct. This is what is called contrapositive. This is contrapositive of the given statement. What was the given statement? If I call this is my statement P, if this is my statement P and this is Q, then Q is contrapositive of P. And similarly, P will be contrapositive of Q. Okay, this is what is called contrapositive. Okay, is this clear to everybody? Let me clear the response. Okay, so somebody has clicked no. Who is it? Yes.
Yes, sir. It's me. I pressed on wrong. I didn't understand contrapositive. Can you repeat it one more time, sir?
Okay. So have you followed? What was the given statement? The given statement is if apple is red, then it is ripe. Okay. Now I'm saying that in case apple is not ripe, then what is the conclusion? What is the conclusion? Did you follow that? Then it cannot be ripe.
Yeah. Yes, sir. Yes, sir.
Right. So if I have to prove the given state, the result, which is the statement that if S, then T, that is equivalent to saying that if T is not correct, if not T, then S cannot be correct.
Oh, okay, sir.
Okay,
Yeah, got it,
so
sir.
these two are the same thing. And we just call this as a contrapositive. Okay, we call this as contrapositive.
Okay, sir.
Okay,
Okay, sir.
right? Because you will keep hearing this word, right? So that is what it means. These two are equivalent. So the contrapositive of a given, if P is given statement, its contrapositive is Q, then contrapositive of Q will be P, right? Okay, fine. So this is clear to everybody. That's good. Right. So let me just to combine this and what we were doing. So now we are having some statement which is a kind of implications, right? So such statements, when you have if, then something, or if something, if and only if something, such things are called implications. These are all statements which are of the type implications. Something implies something and so on. Okay. So let me write. Suppose I have a set X. Okay, X is a subset. Subset. Okay, and let us say if I say given any X in X, take any X in X, then let us say that the statement for this, for given X in X, what is the statement? If X has the property P, so that is a statement, right? X has the property P. This implies that is then X has the property Q. So that is my statement. This is my statement. Given any element X in X, right? So just now what we saw was about the apple, right? Or even in this statement is also of the same nature, right? This says that for every real number X in X, if X mod X is less than 1, then this implies this, right? So in general, this is how we can write. Okay, this is how we can write. Right. So this is your conclusion about every X in X. Now, you see that this property P of any X in X, maybe we can combine these two together. These two together we can combine and write like this. Okay. So we can say that given, or if you want, I can make a set, take all X in X such that X has the property P. This is my another set. Right? This is my another set. Okay, all those X in X which satisfy this property P. Okay, so can we now write this statement? Can we rewrite this statement? Okay. Can we rewrite this statement? I hope you have understood this part. Right, what we are saying. So the statement, given statement was take any x in X. In case X satisfies property P, then it satisfies property Q. So I'm taking all those X which satisfy this property. That's a set, right? Isn't it? So if I look at, for example, if I look at mod X less than 1, so what is my set? Set of all X or set of all real number X such that mod X is less than 1. That is my set. Right? So what will you write? How will you rewrite this? Can you rewrite this given statement? Somebody from group 7? Is there anybody who has clicked yes from group 7? From group 8?
Meerna?
Sir, I'm not sure. Can
Yeah,
we write
you
like
don't have to be sure.
can we write like X has the property Q as it has the property P, because down.
No, I have asked you that this is my new set. Now something is happening in this new set, right? So that is what I'm. Yeah. So that, can you now? I have given you a hint. Can you now tell me what should I write? If I take any element in this set, what happens?
X, that element has both property.
Which property? Any element will always have property P. So
if it has the property P, then it will have the property Q.
correct. So if I take any member of this set, if I want, let me call this set as A. If I take any Y in A, that means take any Y in A. What is my conclusion?
Y has the property P.
Y has property P. No, when the moment I say Y is in A, it already has property P. That is my definition of the set. So I don't have to say that.
Okay.
Right? Then Y has
property
Q. Okay, Y has the property. So this we have written. We have written this statement. We have restated this like this. Is it clear to everybody? Is this clear to everybody? So now it will be very easy to negate. Now all of you can write its negation, right? Good. Still somebody has said no. Yeah, Atul.
Yes, sir. I didn't get what we have written on second statement.
Okay. Have you understood the set we defined? The A?
Yes, sir. Yes, sir.
Okay. So if I take any member of A, if Y is in A, what does it say? When will Y in A? When is Y in the set A?
It satisfies the property P.
If it satisfies the property P. Now, what was the given statement? If X satisfies property P, then what will happen?
It will belongs to X.
Then it will satisfy the property Q. No, that is this statement, isn't it?
Yes, sir. First statement, yes.
Right? So that's what I have written. I have not written anything else. No. If Y is in A, that means it has to satisfy the property P, and therefore it has to satisfy the property Q. Is that clear, Atul?
Yes, sir.
Okay, fine. Good. So if you have doubts, please be honest. Just, don't click yes because somebody else is clicking. Or if I don't click yes, then sir will ask me, why have you not clicked? Okay, so please be honest. Okay, let me clear all the response. Okay, good. So now what will its negation? That is quite clear, right? The negation will be, what will its negation? If there exists some member in A such that Y does not have the property P. Sorry, property Q. Property Q. But then again, you can see here now, this I can put it back in this form. So if I want to rewrite the same thing in this form, what will be this? There exists, instead of Y, if you want, you can call it in X. There exists a X in X such that X has the property P, but X does not have property Q. Right? That is the negation. That is same as saying, there exists X in X such that X has the property Q, but X does not have the property. That is its negation. Okay, this is how we will negate a statement about some member or all member of a set, right, which has this kind of implication. Yeah, Akhila, you have raised your hand.
Sir, it should be X has the property P, right?
Oh, I have written Q here. Okay, that's correct. Thank you very much. That is how we have defined the set, right? Okay, thank you, Akhila. Okay. Right, so this is how you deal with statement which involves this kind of implication and then write its negation. Okay, so you see that this in order to write the negation easily, we thought of combining this, and it helps. So that's what, if you look at in the previous class also, we looked at something where we were dealing with pair of real numbers satisfying certain property regarding the density of rationals. Okay. Okay. So let me go to the next page. Now we will actually deal with maybe some operations on sets. We will look at. So of course, I'm not going to define what is sets, etc. We will assume that you know sets, and also you are aware of the operations. It is just to kind of consolidate your understanding of sets and putting it in proper framework, so that when we see something, we will be able to work with it. Okay. So when you have to define a set, generally you write its elements in curly braces, right? And many times you cannot list all the elements. It is impossible. So for example, if I say set of real numbers, you can't list. So you simply write set of real numbers. Or if I have to write a set, then we will write the set by mentioning its property, right? Mentioning its property. Just now we wrote that set of all X in something satisfying certain property. Okay, so this is what we call a set builder form. We write set in set builder form, but many times, in case it is possible, we write by listing the elements. Okay, by listing the elements. So most often we will write it in set builder form and then work with it. Okay, so so I hope all of you know what is meaning of union, intersection, subsets, and all that. So we will make use of those things. Okay, so first thing is, let us say, if I take this will be notation for empty set. Empty set. Okay. Set having no element, right? Okay. So can you tell me some property that you know about empty set? Some property that you know of empty set. Click yes if you know some property, other than saying that it has no element. Clicking yes is good enough. You don't have to raise hand. Raise hand only when you want to ask me something. I'm sure all of you know. It's just that you don't want to say. Somebody from group 9?
Fatima.
Empty set has no elements.
I said I don't want that. That is what I had said already. I don't want to hear the same thing what I said, no? Something else that you know other than this. Yes. Meghna? Fatima?
If A is a set, then A union phi will be equal to A.
Okay, fine. Megha from group 9?
It is a subset of every other set.
Okay, so it is subset of any set, right?
Yes.
So this is subset of any set. Okay, good. Fine. So let us keep this. It is subset of any set. So if you say any set, okay, let me give you a set. My set is S is set of students here of OFCM 21 group 4. Now write me empty set as subset of S. How will you write? I want to write empty set as a subset of students here, because you just now you said that it's subset of any set. So I'm giving you a set. Now tell me. Tell me. So it looks like that whatever you say, I'm going to make a question out of it, right? Come on, all of you can do it. From group 6, Atul from group 6. Atul?
Yes, sir.
What are you thinking, Atul?
So I'm not getting anything.
What is your thought? Are you thinking something, or you're not thinking at all?
Yes, I'm thinking.
What are you thinking?
What
is that you want? I want empty set as a subset of students here.
Yes,
so what is that we are looking for?
Generally, what comes into my mind is
some property of the students here, which is not satisfied by any student, right?
Yes, sir.
Something which is not true about any student in this group. Can you say now?
They are not the students of OFCM 21G4.
So you're saying that they are not student. They are a student, or they are not saying they are not student. Think of something Something else, some other property. Things, some property about some property. Think. It is quite easy. Okay, so I have at least one positive response. 2. Very good. Come on. Vijesh, tell me.
Yes, sir. The age of student is 100.
Okay, so what? So now tell me clearly. All those students. So you are saying that take all S in capital S such that age of S is 100.
Yes, sir.
So I hope nobody is 100 years old, right?
Yes, sir.
Is there any student who is 100-year-old?
I don't think they'll be able to speak. They
You
don't
don't think
speak.
so. I also think that nobody is 100 years. So,
Yes, sir.
so therefore, this will be empty, isn't it?
Yes, sir.
So we have written, you see that how we have written all those elements in is satisfying this property. Now all of you will have any number of examples now. Okay, let me clear the response. Can you all of think of now another example? He said 100 years. Now it should be easy. Come on, quick. I'm not going to ask what is your example. So you can just like that click. Yes. Right. Instead of age 100, I will say all those students having 20 legs. Right. Or all those students having 200 teeth. All those students who have a PhD degree. Anything I can say. Okay. So, right. Good. So the point is we will always, so if I have a set, let us say I have set X, I have to make some subset A of X, then I will always write A will be written as set of all X in capital X such that it satisfies certain property. That means X has some property. This is how we will write. Okay, this is how we will write. So you see that when we define this set -1 to 1, how did we define all those real numbers such that X is less than 1 and -1 is less than X. And that is a sub. So the moment I say this, all those X such that this is subset of R. Okay, fine. So we will, let me actually give you some exercises because it's already almost time. Okay, so this empty set we wrote as subset of set of students. So the first thing is think of empty set. Write empty set as a subset of real numbers. In let us say at least 2 ways. Second, set of integers. This is a set of integers. Write that as a subset of rational number. And third, think of set of integers again as a subset of real numbers. Okay, so try to write this. Fine. So let me stop here. So please go through this in your discussion room in case you finish all the concept that we have done. You can discuss this. Apart from that, there are other some problems in this. For example, the first problem is consider the statement: if the boy owns a BMW car, then he is graduate. Write this statement in different equivalent ways. For each book in the library, if it has a table of content, then it has index. Next problem is for any integer n, if n square is divisible by 10, then n is divisible by 10. Okay, this I have not written question. So here this is what is contrapositive of this. This statement. Okay, fine. So let me stop.
So the YouTube audience also can take a screenshot of this and they can also work it out.
Yeah, you can take screenshot.
Anyway, the videos will be available till midnight, so you can come back and see the questions also.
Right. So we can just keep this for a moment. And okay, so for YouTube viewers, we can stop live streaming, right? We'll
Yes,
see you
yes.
on Tuesday. Thank you for joining. And